Okay, so today we are going to solve systems with quadratic equations. And our target is, how do you solve a system of equations where at least one system, or I'm sorry, at least one equation is a quadratic? Okay, so we have solved systems before, but the systems that we saw previous to today were linear systems. That means that we had two lines, and we wanted to know where would those two lines intersect, right? Would they intersect in one location? Would they intersect, would they never intersect? Remember, that's when you had two lines that are parallel. Or would they have infinitely many solutions because the two lines were actually the same line? Well, we've been working with quadratics now for several weeks. So you can also have systems of quadratic equations. You could have a line and a quadratic, so like a line and a parabola. Where do they intersect? Maybe they don't. Where do they intersect? Maybe never, maybe in one place, maybe in two places. You could have two parabolas. So two, parabolas, the U-shape, intersect. You could have a parabola and a circle, anything. So what we're going to do, we're just going to deal with a line and a parabola, so a linear equation and a quadratic equation, or two quadratic equations, two parabolas. That's what we're going to deal with today. And there are several ways you can do it. You can graph it. You can use substitution. You can use elimination. I feel like that we have, y'all probably need a little break from graphing, right? I know how much y'all love graphing. So we're going to, today, we're just going to use one of those methods, okay? So are y'all excited? No. All right. All right, so example one. We're going to start with a quadratic equation and a linear equation. So let's have f of x equals negative x squared plus 10x, and g of x equals negative x plus 14. So function f, is that linear or quadratic? That's quadratic, right? We know that because its highest degree is what? 2. And function g is what? Linear or quadratic? Linear, because its highest degree is 1. And I know that parabola, if I were graphing it, would it open up or down? It would open down. And this line, would it have a positive slope or a negative slope? Remember, the coefficient of x is your slope, right? It would have a negative slope. So it's possible that these two functions would intersect 2 times, but not necessarily. Say the parabola opens down and the line is above it and they will never intersect. That would be no solution, right? So we've got 2 solutions. No, bless you, no solution. Or say that the line intersects the parabola right on the vertex. How many solutions would you have then? Just 1 solution. So we have to figure out, if there is a solution, what is the solution? Okay? Anybody have a question so far? So we are going to use substitution, the substitution method, to solve this. We will use the substitution. Good morning. How are you?
Good. Sorry,
What's
it took
this
so long.
for?
For the connection you asked for? The adapter?
Oh, for
For the Mac to it,
the Mac?
right?
No, I don't think so. I mean, I always like a good device. I don't have a Mac, so I don't think it's me. When you were here, when I had my document camera issue and I had Mr. Reavers in here, he didn't have a connection for my computer, but then we figured this one out, and so that might be what you were thinking of, but it wasn't a Mac, so.
Okay.
Thank you, though. Appreciate it. All right, we will use the substitution method to solve this system of equations. Okay, so I want to know, when does function f equal function g? When does function f equal function g? So I'm going to substitute what function f is equal to. Well, function f is equal to negative x squared plus 10x. And I'm going to set that equal to what function g is equal to. Function g is equal to negative x plus 14. We could have also done this with linear equations. If they were both like, say the y was isolated in both of them, and we did that sometimes. We did the same thing. We also use substitution, elimination, and graphing. We're just going to use the substitution method. Okay, so once you set the functions equal to each other, let's make some little notes. Set the functions equal to each other. And then we use substitution. And then you are going to want to set the equation equal to 0. All right, so I want to get everything on one side of the equation, and so that 0 is on the opposite side of the equation. Okay? So I can move everything over to the left, I can move everything over to the right. It doesn't matter. Well, since x squared is currently negative, and that's the term with the highest degree, I prefer that to be positive. So I'm going to move, if I moved it over to the right side, I would add it, right, plus x squared, and it would be positive, so that's what I'm going to do. So the first thing I'm going to do is I'm going to add x squared to both sides. And you could do this in one step, but for the first one, let's just do it one step at a time. So negative x squared plus x squared cancels on the left. And then I have 10x equals, be careful here, are negative x and x squared, are they like terms? No, so you cannot combine them. So out of x squared, negative x and positive 14, what term would come first? X squared, and then what? Negative x plus 14. All right, so almost set equal to 0, but not quite. What should we do now? Subtract 10x from both sides. So on the left side, 10x minus 10x is 0 equals x squared. I'm going to bring it down. There's no like terms to combine it with. What is negative x minus 10x? Negative 11. A lot of kids say negative 10, but remember that's technically negative 1x minus 10x. So negative 11x, and then the positive 14 you'll just bring down. So now we just have a quadratic equation that we need to solve. We know we can solve it by factoring, quadratic formula, or completing the square. Okay? Write that down real quick. Solve the quadratic equation by either factoring, number 2, quadratic formula, or number 3, completing the square. So before I go through all the hassle of factoring, let me just look in my head. I'm going to look in my head and see if it's factorable. You would need two numbers that multiply together to give you a times c. So two numbers that multiply together to give you 14, add to give you negative 11. So would any combination of 14 and 1 work? 14 times 1 or negative 14 times negative 1? No. How about 7 and 2? 7 times 2 is 14. Negative 7 times negative 2 is 14. Would either of those add together to give you 11? No. Are there any other factors of 14? No. So factoring is not going to work, right? Okay. So we can either do quadratic formula or completing the square. I'm going to complete the square. So we know that a is 1, b is equal to negative 11, and c is equal to 14. Oh, by the way, I posted a video yesterday afternoon. You know how on the worksheet from last class, I did problem 1 on the front and problem 7 on the back? Well, I recorded in another class me going over that. So if you were absent or you didn't do it yet and you need a refresher, I did post that on Schoology. You can go back and watch that. So James, we did number 1 together and they had to do the rest on their own. And number 7 together and they had to do the rest on their own. But it's stuff we already learned, it's just a review, okay? All right, quadratic formula. You all know and love. You love it, right? Yeah. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah. All right, so surely we're getting good at the quadratic formula by now. We've had to do it a lot. So let's substitute in for our variables. X equals, what is the opposite of b? 11, because b is currently negative 11. So when you subtract a negative, it becomes positive. We just say the opposite of. Plus or minus the square root of b squared, so that's negative 11 squared. When I square that negative, is it going to stay negative or become a positive? Become a positive. Minus 4 times a is 1 times c is 14. All over 2a, so 2 times 1. All right, let's start simplifying under that radical. So let me bring everything else down. I have x equals 11 plus or minus the square root of. Now, negative 11 squared, does that mean negative 11 times 2? No, it means negative 11 raised to the second power. So I can either do negative 11 times negative 11, or this button right here, the x squared button, that will square it. And it even squares the negative. Now, in most calculators, you have to put the negative in parentheses if you want to square it. This calculator doesn't, which I think is strange, but it just squares whatever you put in there. So negative 11 squared is positive 121. And then I beg of you, I'm still begging for you to do the minus 4ac part all at the same time. So let me figure out my sign first. What's a negative times a positive times a positive? A negative. So when I know that when I multiply all that together, I'm going to be subtracting it. Sometimes you're adding, it depends. So now I'm just going to multiply the absolute values. So 4 times 1 times 14. And I get 56. So I'm going to be subtracting 56 from 121. And that whole thing is over 2 times 1 is 2. Feel cool with that? Run it out of it. Okay, so 121 minus 56 is 65. So I'm going to rewrite this. X equals 11 plus or minus the square root of 65 over 2. And I don't know where that is on my graph. I don't know where 11 plus the square root of 65 quantity divided by 2 is on my graph. So I am going to convert the square root of 65 to a decimal, okay? I'm going to take the square root. I know 65 is not a perfect square, so I have to use my calculator. So x equals 11 plus or minus the square root of 65. I just put 65 in my calculator, and then what do I hit? The square root button. And I get approximately 8 point, let's go, we don't want to round to 8, 8.06. All over 2. I can simplify this further. I want to know exactly what those two answers are. Well, an approximation because we just rounded, so it's not exact. So I'm going to make 2 separate equations. One of them will take the positive 8.06 into account. The other one will take the negative 8.06. So I have 11 plus 8.06 quantity divided by 2. And I have x equals 11 minus 8.06 quantity divided by 2. It's not just the 8.06 that's being divided by 2. Now, I told y'all this the other day. If you put in your calculator 11 plus 8.06 divided by 2, it's going to calculate 8.06 divided by 2 first, and then add 11 to that. It's just doing order of operations the way you entered it. When you have a fraction, I've got to simplify that numerator before I can divide by 2. So it's imperative that you do 11 plus 8.06 equals, and then divide by 2. Okay, if you don't, you put it all at the same time, you're not going to get the right answer. So I'm going to do 11 plus 8.06 equals, I get 19.06, divide that by 2, and I get 9.53. On the other one, 11 minus 8.06 equals 2.94. Divide that by 2, and I get x equals 1.47. Now remember, usually when we use the quadratic formula, it's because we're graphing a quadratic, right? So usually this tells us where the graph crosses the x-axis. But remember, that's not what we're doing here. We were trying to find where this line and this parabola intersect each other. That's what we were trying to find. So this is not where the graph crosses the x-axis. We combined two equations together is what we did. And so while I'm talking, I'm trying to pull up Desmos. I don't know what this is doing to my video because it says my screen sharing is paused. And I've not actually done this while in a video. So we're going to see how it works out. But I'm going to get on Desmos and we're going to check our answer to see if it's true. Does this line and this parabola intersect in these two locations? Now, we didn't find the y value of the location, right? We only found the two x values. And we don't have to find the y. We just want to know what are their x values, where they intersect. Come on, graphing calculator. Okay, let me go back, see if I can figure out how to share my screen. Yes. Oh, really? Okay, let me go back. Sorry, everyone at home. I am not a professional video maker. I'm probably going to mess it all up. And I promise you, each problem won't take this long. I'm just over explaining this one. It's stuck right now. Okay, so let me just exit this page. You might have to tell me again. Everything's just stuck right now. Oh, snap. Let's try to reload. All right, well, so that's not going to work. Or I'll have to do it again, not that it won't work. So let me see if we can see this in my graphing calculator. And those of you at home, I know it's stuck. Just to try to do that. Okay. Okay, so what did you say I should push? Just screen? Screen should be anything that I'm on? Okay. Okay. So hopefully at home they can see this because There's no one for me to ask right now. All right, so let me try to do this in my graphing calculator. So we haven't used these things here yet because I'm not supposed to share my calculators. I don't know how well you can see that. But I'm going to enter both equations that we're graphing. So function f was negative x squared plus 10x, and function g was negative x plus 14. And to see the graph, so I can't really see much of that graph, right? So I'm going to zoom out, zoom out, zoom out. Come on, this is just going crazy. All right, well, let's look at our table. Our table of values at 9.53, which I don't think is a decimal. Okay, so it does it at 9. It won't be exact. Can y'all see that on 9? I know it's light. But my first function, when x is 9, my y is 9. Right here, the x value for both of these is the same. So I know that that's right. And at 1, it should be the same as well. No, it's not. 1.47. I should just throw this video off. Nothing's working right for me. Let's just move on. How about it? I should probably read this instead of here. We'll see. Okay, but pretty much it's all math that we already know how to do, right? I didn't really show you anything new there. So let's do example 2. This time we're going to do 2 quadratic equations. So we are going to solve the system of equations. And a lot of times when we have systems, we use the bracket. And so we have f of x equals x squared minus 2x minus 5. And we have g of x equals negative 2x squared plus 5x plus 1. Okay, so we're using substitution. Just like we did in the last one, we're going to set the functions equal to each other. So I'm going to set function f equal to function g. Everybody okay with that? And then I'm going to substitute what was function f equal to? Well, it was equal to x squared minus 2x minus 5. So I'm going to replace function f of x with x squared minus 2x minus 5. And then function g, I will substitute with what function g was equal to, which is negative 2x squared plus 5x plus 1. So in the last equation, we were doing a line and a parabola, right? This time we're doing 2 parabolas. Well, I know function f, is it going to open up or down? It's going to open up. And function g is going to open down. So it could intersect 2 times, right? Could it intersect never? Yeah. Say if one was opening up and the other was opening down and their vertexes, one was above and below each other, they're not going to intersect, right? Could it intersect just one time? Yeah, because they could meet at their vertex, right? So we would have 1 solution, 2 solutions, or 0 solutions. Oh, sorry, can't see that. And the last one we had 2 solutions. So what we're going to do is we are going to move everything to one side of the equation. Preferably, we want our leading coefficient to be positive. Since my highest degree is 2, these are both quadratics, we want the squared terms, the quadratic terms, to be positive. So if we want that to happen, what should we do? Should we move x squared to the right or negative 2x squared to the left? Move negative 2x squared to the left. So I'm going to move function g over to the left side. Now I can do this in 3 steps because I have to move negative 2x squared, I have to move positive 5x, and I have to move positive 1. But can we just do it all in 1 step? Yeah. So I'm going to line everything up. Okay, I'm going to put like terms above or below each other. So I'm going to add 2x squared to both sides. So I'm going to line that up with its like term. So the 2x squared on the right will cancel. I'm going to subtract 5x from both sides, line it up with its like term, and I'm going to subtract 1 from both sides. So on the right side of the equation, we should now have 0. All right? On the left side, let's combine like terms. Is x squared plus 2x squared 2x squared? Then stop doing that. Y'all tell me that all the time. Remember, it's technically 1x squared. And 1x squared plus 2x squared is 3x squared. What is negative 2x minus 5x? Negative 7x. What's negative 5 minus 1? Negative 6. So let me see. If I were going to factor that, I would need 2 numbers that multiply together to get negative 18 and add to get negative 7. Does that sound like we could do that? Multiply to get negative 18, add to get negative 7. 9 times negative 2 is negative 18, and 9 plus negative 2 is positive 7. But if we just change it to negative 9 and positive 2, that'll work, right? Okay, so we can factor this. Yay. So let's factor. We know that A is 3. Oh, and there's not a GCF, right? Because if there was, we would take that out first. B is negative 7, and C is negative 6. Okay, so we will make our little T-chart. We need 2 numbers that multiply together to get A times C. And which is A times C is negative 18. And 2 numbers that add together to get B, which is negative 7. And we just said that negative 9 times positive 2 is negative 18. And negative 9 plus 2 is negative 7. So it's factorable. So we know once we have our numbers from the T-chart, we make 2 sets of parentheses. We had a test on this. We already know how to do this. If you bombed the factoring part of the test, hey, let's retake it. Let's do it before a break. Schedule a time with me. If you bombed quadratic formula, but you get it now, reschedule it. However, you have to know how to simplify the radical, not turn it into a decimal for the test. All right, so our variable being used is x. And the second term in each step comes from the T-chart. So negative 9 and positive 2, not negative 18 and negative 7. Sometimes we make that mistake. Will we need to do the old divide and slide? Yes, because A is a number other than 1, right? So if we can divide evenly, we divide. If we can't, we reduce and slide. Negative 9/3, is that going to be a divide or a slide? A divide. So I get x minus what? 3. 2/3, divide or slide? Slide. Can I reduce? No, because if you can, you have to reduce before you slide. Remember, that only happens if they're both slides. That's the only time I've ever seen it reducible. So we slide the denominator on up and put it in front of the x. So that becomes 3x, and we just bring down the plus 2. So I am completely factored here. But have I solved the system? No, I have not solved the system. What do I have to do to solve? Set each factor equal to 0. I've got 2 factors. X minus 3 is a factor. Set it equal to 0. 3x plus 2 is a factor. Set it equal to 0. And then I just solve them both. We know how to do this. Been doing this since at least middle school. So x is 3 is one of my solutions. And so we have 3x equals negative 2. We will divide by 3. And x equals negative 2/3, or if you converted that to a decimal, it would be negative 0.6 repeating, right? Either or is just fine. Those are my solutions. Are y'all ready to try one on your own? Oh, so these 2 parabolas intersected twice, right? So they would look, if we graphed them, they would look more like this. And I would show you on Desmos, but I'm scared to do that. Next time, I will try to open Desmos first before I start my recording, and then try what you told me to do the whole. I didn't even know you could do that. I thought you had to like share different screens. I've just never noticed it before because I've only shared my document camera. So I always just pick document camera. Right. Yeah. Right. I like it. I'm in. I'm going to try it, but not during this video. All right. Are y'all ready to try one on your own? Example 3. Now this is going to be a line and a parabola. So it will be like the first problem. So my system is y equals x squared plus x minus 2. So that's my parabola, and it opens up, right? And my other one equation is y equals negative x plus 1. Now, they use y's this time instead of f of x and g of x, but y'all know how to set them equal to each other, right? Okay. While y'all are doing that, I'm going to try to do this again. And for those of you at home, just work this on your paper. Don't mind your screen. Question. All right, so let me go ahead and go over this. I can't figure out how to show you this. I want to get this set equal to 0. My leading coefficient is x squared. The other equation is just linear, so it doesn't have a quadratic term, okay, because it's linear. So since x squared, that's my only quadratic term, and it's already positive, I'm going to move, I want to keep it positive, so I'm going to move everything over to the left. So I'm going to add x to both sides. And so that'll cancel, and I'm going to subtract 1 from both sides. That way, on the right side of the equation, I will just have 0. On the left side, I have x squared. What is x plus x? 2x. And negative 2 minus 1? Negative 3. Okay, let me think. Could I factor this? Are there two numbers that could multiply together to give me negative 3 and add to get positive 2? What is it? Positive 3 and negative 1? Sounds good. So let's factor this. So much easier, right? And we know there's no GCF. A is 1, B is 2, C is negative 3. So I am going to, we already said it, but I'm going to show my work. Find two numbers that multiply together to give me A times C. A times C is negative 3. And two numbers that add together to give me B, and B is positive 2. And so we said positive 3 times negative 1 equals negative 3. And 3 plus negative 1 equals positive 2. So boom, positive 3 and negative 1 is what works. So now that we know what to put in our parentheses, we'll make our parentheses. The first term is whatever the variable is that's in the equation, which is x. And then our numbers come from the t-chart. It was a +3 and a -1. Do we need to divide and slide? No, because a is 1. If you divide by 1, nothing changes, right? If a is any number other than 1, you must divide and slide. What are you doing? What are you doing? Huh? That's a calculator? Looks like a phone. Is that the calculator on your phone? I got more. No, just get another one so it doesn't look like you're texting. All right, since I'm not dividing and sliding, finish factoring. I set each factor equal to 0. Solve each equation. Whoops, it's supposed to be -3. So one of my solutions is -3. The other one is +1. So this parabola and this line will intersect at -3 when x is -3 and when x is +1. That is not an ordered pair. I only am finding the x values where they intersect. They also have y values, but I'm not asking you to find that. Understand? Okay. So let me try this again with my graphing calculator. I entered the two equations. I have the quadratic equation, I have the linear equation. And I'm going to hit my graph button. Okay. Does it look like that the ordered pair where these are intersecting, does that look like the x value of that ordered pair is -3? Yeah. Sorry, it's being glitchy. All right. And then the other ordered pair where they intersect, does it look like the x value of the ordered pair where they intersect is +1? Yeah. So I think we did it right. Those ordered pairs also have y values. We're just finding the x values. Okay? Yes. Okay, Lisa's in there. When she's out, you can. Oh, thank you. Yes, good. Did everybody finish copying this one? For this one? Oh, nice. Okay. So we can see a little better on this phone. So you can see if we zoom in right here, here's one ordered pair where they intersect. So it definitely looks like if this is -2 and this is -4, that's an x value of -3. And if we wanted to find the y value, it would be +4. We could just plug x is -3 back into either equation and find the y value. I'm just not asking you to do that. And the other ordered pair where they intersect has an x value of, if this is 0 and this is 2, that's 1, right? Which is what we said it would be. And it has a y value of 0. We just weren't asked to find that. Smart thinking. I could have just got my iPad out. You want your phone back? Or we're gonna do one more. But I'll let you enter since you're probably better at it on your phone than I am. All right, one more. So this one was one quadratic and one line. I'll have you do one more on your own. Two quadratics. The same thing, right? You just get everything set equal to 0. Either going to factor use the quadratic formula.
On Zoom? Yes, you're on Zoom.
Mm-hmm.
You mind if I check if Zoom is getting this?
Sure. Except, do you know how to log into, like, I don't know what the code is that I'm on right now. I think so. Okay, I'm making this one up, so hopefully it works out right. So this is example 4, right? Let's do f of x equals 2x squared plus x minus 3, and f of x equals negative x squared plus 3x plus 4. Like I said, I'm totally making that up. So hopefully it's not too crazy. They should intersect, so I don't think it's too crazy. Lincoln. It's a first period now. So new meaning link. It'll be under my parallel. You see it? All right, did y'all get an answer? Yeah? What did you get? 1.9 and negative 1.2, is that what you said? If you're trying to enter, it should give me a notification. What do you mean? Hang on, 657. Show me the invitation. Right there. Here you are. Okay. Okay, and that's all you should be seeing right now. Perfect. All right, so sorry, people at home, we are just trying to figure some things out. So I'm going to set these equal to each other. So I'm going to set functions. Oh, I call them both the same thing. I probably should have called one of them something different. My bad. So I'm going to set function f equal to function g. And I'm going to substitute. Function f is 2x squared plus x minus 3. Set that equal to function g, which is negative x squared plus 3x plus 4. So this is a parabola set equal to a parabola. And I want to keep the quadratic term positive since it's my leading coefficient. So I'm going to move, in order to do that, I'm going to move everything that's on the right over to the left. And I'm just going to do it in one step. You can do it in 3 separate steps if you want to. Yes. No, I just want to keep the quadratic term positive. And if I move 2x squared over to the right, it's going to be negative. And if I'm factoring, I don't want it to be negative, you know. So I just would like to keep it positive. So I'll add x squared to both sides. I'm going to line up like terms. Subtract 3x. Subtract 4. On the right side, everything cancels and I have 0 left. On the left side, what's 2x squared plus x squared? 3x squared. X minus 3x. It's minus 2x because positive 1x and negative 3x make negative 2x. And what about negative 3 minus 4? Negative 7. Will we be able to factor this? Two numbers that multiply together to get 21, add to get negative 2. No, okay. So quadratic formula it is. We've got a quadratic. Quadratic formula always works. We know A is 3, B is negative 2, C is negative 7, right? So we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah. X equals, what is the opposite of b? Positive 2. Plus or minus the square root of b squared. So that's negative 2, quantity squared, minus 4 times a is 3 times c is negative 7 all over 2 times 3. So we have x equals 2 plus or minus the square root of negative 2, quantity squared is positive 4. Let's figure out what's my sign going to be for negative 4ac. I've got a negative times a positive times a negative. I'm going to be adding, right? Okay. And then 4 times 3 is 12. And 12 times 7 is 127. Oh, no. 84. 12 times 7, 84. So we're adding 84. It's not always subtract. It's whatever. Negative 4 times positive 3 times negative 7. That sign changes to positive. Okay, some of y'all put negative no matter what. And it's not always the case. Be careful on that. 2 times 3 is 6. Any questions so far? So we have x equals 2 plus or minus the square root of 88 quantity divided by 6. Is 88 a perfect square? No, and we don't have to simplify the radical here. I'm looking for an approximate answer, not an exact answer. When you leave a radical in your problem, you're getting an exact answer. When you turn it into a decimal using your calculator, you're approximating because you're rounding, okay? And we're just approximating our answer. So the square root of 88 is approximately, let's go with 9.4. So x equals 2 plus or minus 9.4 quantity divided by 6. I need to simplify that further. I don't know where this is on the graph. So I'm going to separate this out into 2 separate problems. One will be dealing with the positive 9.4, and the other one will deal with the negative 9.4. So I'm going to say x equals 2 plus 9.4 quantity divided by 6. And the other one will be x equals 2 minus 9.4 quantity divided by 6. Do we leave our answer like that? Am I going to put 2 plus 9.4 divided by 6 in my calculator all at the same time? No, you're going to get the wrong answer if you do. Your calculator is going to see the order of operations, and it's not going to simplify the numerator first. So we're going to do 2 plus 9.4 equals, and then divide by 6. And I get 1.9. I like to check my work. 2 plus 9.4 equals, it's easy to push the wrong thing. So 1.9 is one of my solutions. And I have 2 minus 9.4 equals divided by 6. So I believe the other answer is negative 1.2. Is that what we got? So equals negative 1.2. Now I can check myself with a graph. We have been graphing by hand, so we could totally graph these by hand. We're not going to. I had planned on it, but I think we need a break from graphing. However, if you just use Desmos to give me your answer, do you think I'm going to give you credit for that? No. I don't want to know that Desmos can find the answer for you. I want to know that you can find the answer algebraically, okay? So, I got my iPad out. Oops, I don't want to show you my passcode. And I will enter these two equations. Sorry about that glare. So I have 2x squared plus x minus 3. 2x, oops. It's different than it is on the computer. How are they squared? Well, I'm afraid I'm going to get it locked up. When I pull up Desmos on the computer, oh, 2x squared, duh. 2x squared plus x minus 3 plus x minus 3. Okay, so there's the graph of function f, parabola, and function g, negative x squared plus 3x plus 4. Probably not making for a very pretty video. What can you do? So negative x squared plus 3x plus 4. All right, so we can see these graphs, remember, we're looking for the x values where they intersect. So I know that x value was negative 1.23. We said negative 1.2, right? We rounded. They rounded one place further. And it also intersects right here at negative 1.897. We said, or I'm sorry, positive 1.897. We said positive 1.9. Same thing, we just rounded differently. So I would say we did it correctly. Right on? But again, if you just put in decimals to give me your answer, you are not getting credit for that. You have to show me your math. So I'm not giving you homework today. What time is it? We're going to do a ticket out the door. Real quick. Ticket out the door. Before you leave, I want as much work as you get done. Ticket out the door. And we're just going to do a quadratic and a line. Okay? So please title this TOTB. Put the date on it so that I know when the assignment came from, and of course your name. Show me all your work. And this is your ticket out the door. Mm-hmm.
And then I think if you put, just go to your homepage or something.
Because I'm only on the share screen before. Oh, it did. Really? Or is that yours, computer? Okay, so hold on, let me see. X squared. Because all I did was share, I believe I'm only on share the screen for this. document camera.
You're on share screen.
What, hon? Oh, hold on, go back to the, so he can see that.
You clicked on share screen because this is a tab or something that you can open. It can share this through your screen.
Okay.
It's not sharing that, it's sharing the screen because it's an app or tab it will show up.
Well, thank you. I did not know.
It's easy.
Huh? And for those of you at home, I'm going to go ahead and stop this video. And I'm sorry, it is not the best video we've ever had. I'll try harder.